Yes, students, moving to your second question. Let Pn is a to the power n equal to 3 raised to the power n minus 1, 3 raised to the power n minus 1. Each entry of a square matrix of order 3 as 3 raised to the power n minus 1. Now, first of all, we shall prove that the value of Pn is true for n equals to 1. So, I get P1 as a to the power 1 equal to 3 raised to the power 1 minus 1. Each entry 3 raised to the power 1 minus 1. Now, we know that 3 raised to the power 1 minus 1 is equals to 3 raised to the power 0, which is equals to 1. So, I got A1 as a square matrix of order 3 with each entry 1. So, P1 is true. Now, let us assume that Pn is true for n equals to k. So, Pk is क्या हो जाएगा बेटा? It is a raised to the power k equal to 3 raised to the power k minus 1, 3 to the power k minus 1, a square matrix of order 3 with each entry 3 raised to the power k minus 1. Mark this as your first equation. Now we shall prove that pk plus 1 is true whenever pk is true. Now that means that pk plus 1 is a to the power k plus 1 equal to 3 to the power k, each entry 3 to the power k. Right? Mark this as your second equation. Now a raised to the power k plus 1, if I take the left hand side, then a raised to the power k plus 1 can be written as a raised to the power k into a. Now from first equation, put the value of a raised to the power k as 3 raised to the power k minus 1 each entry. Okay, into 1 1 1 1 1 1 1 1 1, that is your A matrix, means a raised to the power 1. Then by using the matrix multiplication, I got 3 raised to the power k minus 1 plus 3 raised to the power k minus 1 plus 3 raised to the power k minus 1, which can be written as 3 times 3 raised to the power k minus 1. So I got each entry of a square matrix of order 3 as 3 raised to the power k minus 1 into 3, which is equals to 3 raised to the power k, and that is equals to my RHS. So the result is true for n equals to k plus 1. Hence, by the principle of mathematical induction, Pn is true for all n.